2, explain what happens as a reaction starts with a delta G that's less than 0, so it's negative, and then reaches the point where delta G equals 0. Okay, so let's draw this out. We have basically a reaction. It does not matter, so let's just write a random reaction, right? Let's just say that A plus B goes to C. Cool. Whatever you want A and B and C to be, I don't really care. Doesn't really matter for this reaction. Just as long as you have some things on the left, you got something on the right, and yeah. So we're basically starting from a delta G, so a Gibbs free energy of less than 0. So I know that I have a negative value, and I am going to a delta G that is 0. What's actually happening with the reaction? Okay, well, delta G of negative, right? We should know what that means. Anytime that you have a delta G that's less than 0, which is a negative value, that means that your reaction is spontaneous. So in the beginning, when this reaction is starting off, they're telling us that it's going to be a spontaneous reaction. Spontaneous reactions means that in order to produce the product, you don't need any external amounts of energy to make this process go. A and B are going to spontaneously, right? It's just going to happen like that. They're just going to turn into C. So that's what spontaneous is that it's going to favor, production of C. But now, all of a sudden, is that as this goes on and on and on, and you're making more and more and more and more C, the delta G is now turning to 0. Well, when a delta G reaches 0, that means that you're at equilibrium. Okay, so now we're dealing with 2 chapters here, right? So chances are, if they're asking this type of question, you might have done your equilibrium chapter. So just remember what equilibrium means, right? Equilibrium is talking about a K value, right? Now, there's 2 different equations, right? Or 2 different constants. There's the equilibrium constant, and then there's that Ryotian. I just combined the 2 words together. It's a theme on this channel. Ryotian. Reaction quotient. Ryotian. Anyway, so we have K, the equilibrium constant, and we have the Q, which is the reaction quotient. Now remember, at equilibrium, that means that these are equal, because literally you're at equilibrium. The Q has to be equal to that K value. At equilibrium, that means that the rate of the forward reaction equals the rate of the reverse. But wait a minute, we were talking about spontaneous. We were going all the way this way in the beginning. So we basically came to all one way to the same rate back and forth. Well, now the only thing that we have to add here is what's going on with the Q and the K. Now, remember, if we're going to the product side, that means that we are in an unsaturated solution, right? You want to think about it in terms of KSP, or if you just want to think about it in terms of K, we're making more product. Remember, if you're making more product, your K value is going to be a large value. And whenever that you're going towards the product, the Q is always less than the K. Anytime that your Q value, your reaction quotient, is less than K, that means that you need to make more product. And you need to make more until your Q and your K are equal. So that's the difference here. It's the ways of the arrows. So anytime you have a Q that's less than K, you're going to be going to the products. And then it's going to keep happening until you reach a delta G of 0. And then you have that equal rate of forward and backward. And then delta G that's greater than 0, the reaction is non-spontaneous. That would be going in the reverse direction because you need that extra oomph, that extra energy to produce the product. But that one was not stated here, so we don't have to worry about that. But that's basically what's going on here. I really hope this helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel, And tell your friends, tell your classmates about this cool educational channel. We would love to help anyone that we can help. So we have physics and math videos on the channel right now with more subjects coming. So just check back. Okay? Love helping you guys. Stay well. Be well. And I'll talk to you soon. Bye-bye.